Imagine you visit a website several times, for example our website at the University of Adelaide. While we could download the page from the web server every time, this would be a waste of resources, especially if the page rarely changes. An obvious way to improve this is by using a web cache which keeps a copy of the page handy. The next time you request a page, you can check this web cache first. If the page is there, then the cache can send it to the browser directly. If not, then the page still needs to be downloaded from the server, but once it's downloaded, it's stored for future use. A couple benefits of a web cache are that pages load faster, which improves the user experience, and frequently accessed pages don't need to be downloaded as often, which reduces the network and server load. In this example, you already know that you can have a local cache on your machine or device. However, we can expand this concept to improve performance across an entire network. But how? Imagine you have not visited the University of Adelaide's website for a while, but another user on your network has. The next time you attempt to load adelaide.edu.au, wouldn't it be great if you could load it faster using the copy cache for that other user? While this is a good idea in theory, it is difficult to scale this efficiently on a large network using a single cache server due to the sheer number of websites and users. Instead, we can spread the cache across many machines to share the load. Consider this scenario of a distributed cache across 1,000 machines and a single page request. For this particular website request, how do we know which of those 1,000 machines has the cached copy of that website? Don't worry, hashing has us covered. Much in the same way we use a hash table to find data in a local set, we can use the same technique to determine which machine should have that website cached by hashing the website's address. We can then query that machine and it can either give us the cached copy of the website or fetch a fresh copy if it doesn't have a cached copy or that copy is too old. This approach does pose some challenges, such as when we add machines to the network. If you're interested in learning more about these, feel free to check out some of the resources below. Okay, now that you've seen one example of hashing in practice, try the next activity, where you can practice using hashing in another real-world application.